La 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 Sir Eman's world tum 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 la 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 Sir Eman's world tum tum tum. You will learn physics 'cause I teach you in Sir Eman's world. Okay, so welcome to another episode of Sir Eman's world. So this time around our lesson would be all about heat and temperature. Hooray! So before that, we are going to have our usual segment before the start of each lesson, which is the guess the drawing. Guess the drawing segment. So what drawing are you going to guess today? So again, the first person to guess the what's being drawn for each section would, well, win one quiz point plus one quiz point. Hey, one quiz point isn't that bad after all. So guess what's being drawn over here. Okay? Okay, so this looks interesting. Okay? So what is this? So what is this picture? What's this? Okay? And so the clue is, we have a clue. I'm going to give you a clue. The clue is Little Prince. Okay? So whoever gets to direct message me in Edmodo what this thing is over here, okay, you would know, you would get your plus one quiz point. Okay, so our lesson for today would be all about heat and temperature. So let's define what is heat and temperature. Let's find what temperature is first. So what is temperature? So temperature, its qualitative definition is that it is the measure, of the hotness or coldness of a body. Okay? So when we say something is hot, we say it's a high temperature. When something is cold, it means it has a low temperature. So hot objects, we say, has high temperature, and cold objects, we say or tell that is having low temperature. But aside from that, we also have the quantitative definition for temperature, which means, well, measurable. And that other definition for temperature is that aside from being the hotness or coldness of the body, we define temperature as the measure. It's the measure of the average kinetic energy. Oops, wrong spelling. You have there the average kinetic energy of a body, or let's say a system. So it would be handy if you write this down. Okay? And so we all know that, okay, all matter is made up of tiny particles called atoms. And these atoms, when they combine, they form molecules. Now, atoms and molecules are always on the move. They are always moving. And we all know that when something is moving, it possesses kinetic energy. Now what happens is that when we add up energy, when we give energy or add energy to these atoms and molecules, when we hit them, is that this kinetic energy increases. Of course, when there's an increase in kinetic energy, the temperature also increases. Also take note that temperature is just a measure of the average kinetic energy of a body. Later on, we are going to differentiate heat with that of temperature. Okay, and so how do we measure temperature? Temperature is obviously measured using a device called a thermometer. So the thermometer, as well as a device used for measuring temperature. Okay, so let's now be familiar with the different temperature scales that are used. So what are those different temperature scales? So one scale, the first scale I believe that everyone is familiar quite, is the Fahrenheit scale. It's not really that popular here in the Philippines. So the Fahrenheit scale is an English unit, and likewise it's only used in English countries like the United States. Anyways, an important thing to note to the Fahrenheit scale is a temperature scale. It is based on the average human body temperature. Okay, so that's what Fahrenheit bases temperature from. And according to Fahrenheit, the average temperature for a human, the average body temp, is about, or is approximately 100 degrees Fahrenheit. And from there, Fahrenheit based the different, the other temperatures, water bodies. It's like making 100 degrees Fahrenheit the basis for all other temperatures of other objects. Let's say, for example, according to Fahrenheit, if we're going to draw a number line over here, okay, we have here the human body temperature over here, which is about, it's about 100 degrees Fahrenheit. And according to Fahrenheit, okay, so using the human body temperature as the basis, according to Fahrenheit, the freezing point of water is about 32 degrees Fahrenheit. And likewise, the boiling point of water, Fahrenheit says, the boiling point of water is 212 degrees Fahrenheit. So that's how Fahrenheit came up with a scale. He used the human body as the basis for the scale. Okay, the next scale that we're going to be familiar with now is the Celsius scale. Okay, now the scale number 2, we have here the Celsius scale. The Celsius scale, unlike the Fahrenheit scale, Celsius being a really scientific person, he didn't base his scale on something that changes from time to time, like the human body temperature. Instead, Celsius based it on something that is constant. He knew is constant, and that constant that Celsius bases his scale on is the temperature, okay, of the freezing and boiling points of water. So it's a scale that is based on the freezing and boiling points of water. And so what Celsius did, of course, we also know that the Celsius scale is also called as the centigrade scale, because we'll see later on the reason why. So let's draw the same line that we have had earlier with the Fahrenheit scale. Okay, so let's have the same scale over here. So over here we have here to Fahrenheit, sorry, Celsius. Over here we have the freezing point of water, and over there we have the boiling point of water according to Celsius. And what he did, since this is also called as the centigrade scale, he placed 100 graduations in between. So imagine that is 100 graduations. So that's why it's called as the centigrade scale. So starting with the freezing point is given the freezing point of water, a numerical value of 0 degrees Celsius, and then the boiling point as 100 degrees Celsius. So if you would notice right now, okay, if you would notice, between the freezing and boiling points for both the Fahrenheit and the Celsius scale, for the Fahrenheit scale, you would see, okay, that for every, from the freezing to the boiling point of water, we would have 180 degrees. And for Celsius, okay, we would have just 100 degrees for the Celsius scale. Now to solve for the Fahrenheit temperature, okay, you just manipulate this one. By the way, simplifying this ratio, you would get what? You would get 9 over 5. Okay, get 9 over 5. So for every 9 degrees rise in Fahrenheit temperature, you would get a 5-degree rise in the Celsius temperature. So solving for the Fahrenheit temperature in degrees Fahrenheit is given by the factor, by the formula, multiply the temperature in degrees Celsius by the ratio 9 over 5. Sorry, that doesn't look much like a 9. Multiply that by 9 over 5 times the temperature in degrees Celsius. But take note, degrees Celsius, well, starts with a 0, freezing point, and the boiling point should, and the freezing point for Fahrenheit starts with 32. So to even them out, well, you just add 32 in the equation over here, and then you will get the formula for the conversion of temperature from degrees Celsius to degrees Fahrenheit. Likewise, you just manipulate this equation, you will get the formula for converting degrees Fahrenheit to degrees Celsius. But let's just explain it. Okay, so for getting the temperature for degrees Celsius, given the Fahrenheit temperature, okay, but see, we analyze the following. You would notice that the Fahrenheit temperature is 32 degrees greater than the freezing temperature for water. The freezing temperature for Fahrenheit is 32, the freezing temperature for water is 0. So to even that out, okay, we must first subtract 32, okay, 32 degrees from the Fahrenheit temperature before multiplying with the ratio. Looking over here, okay, we would get 5 over 9. So what we have over here this time around is the formula for converting degrees Fahrenheit to degrees Celsius. And the next scale that we're going to talk about or study is a very familiar scale to everyone. And that scale is also known as the Kelvin scale. Okay. So the Kelvin scale also known as the absolute temperature scale. It's called as such. It's called as such because, well, all the values for temperature in the Kelvin scale are positive values. Okay, just like for example in mathematics, when you say the absolute value of a number, you're getting the positive value for that number. Okay, so we say that the lowest possible temperature for the Kelvin scale is a 0, and that temperature 0 Kelvin is called as the absolute zero temperature. Absolute zero temperature. At absolute zero temperature is defined as the temperature at which all molecular motion stop. Motion stop. And at that temperature, okay, that temperature is 0 Kelvin. That's not okay, okay? That's 0 Kelvin. So according to Kelvin, well, let's just extrapolate the value, the lowest possible value for that. According to Kelvin, the lowest possible temperature is 0 Kelvin, and it is measured to be equal to negative 273.15 degrees Celsius. Okay? So take note, class, that Kelvin is written with no degree signs whatsoever. Okay? So when we are solving for the Kelvin temperature, for example, given the temperature in degrees Celsius, we use the following formula to convert from Celsius to Kelvin. So you just have the temperature in degrees Celsius, you just add 273.15 to the temperature in degrees Celsius, and then you would get, well, conversion from Celsius to Kelvin. Likewise, we wanted to solve for the Celsius temperature, given the Kelvin 1 degrees Celsius is equivalent to Kelvin temperature, and then subtract 273.15. It's pretty much straightforward because according to Kelvin, for every 1 degrees or 1 Celsius degree rise in temperature, okay, it's equivalent to 1 Kelvin change in temperature. That's why scientists love using the Kelvin scale. It's just positive. It's like always positive thinking. So those are all the temperature skills that you just need to be familiar with in order to survive physics. So I hope everyone gets familiar with that. So just remember, if you wanted to solve for each of the following, you just use the formulas that we have had. Okay, so that's all. Goodbye and God bless.